The target levels I've got for minerals from the top on sulfur is 75 parts per million. In many cases in the eastern half of North America, we've got a fairly heavy annual rainfall, and sulfur tends to leach. It's an anion, it tends to leach out of the soil. So in many cases, sulfur is a systemic deficiency in many soils. I looked for a level of 75 parts per million as a sufficiency level for biological systems. After sulfur, I've got phosphorus. This is a Mehlich-3 phosphorus, which is one of many different types of ways of testing the mineral. I look for 75 parts per million, again, to be present in the soil. Phosphorus is, again, an anion. It does leach or get tied up tightly in the soil, and so it's critical that you have a functional fungal ecosystem in your soil for phosphorus availability to be maintained throughout the entire growing season. At any rate, 75 parts per million means that there's enough phosphorus present in the soil. It does not mean it's available in the growing season. It means that simply it's there. But that's what we're worrying about right now. We'll deal with the other things later. Next, I have calcium. I generally look for somewhere between 65 and 75% base saturation on calcium. That'll differ based on the exchange capacity of your soil. Perhaps we should talk about exchange capacity as well. Exchange capacity simply means how big is your soil. I liken it to a gas tank. If I've got a truck with a 20-gallon gas tank, that can do a lot of work. If I've got a moped with a 1-gallon gas tank, it can't do so much work before it needs to be reloaded. So a sandy, light soil with a low organic matter would be more like that 1-gallon gas tank. It can do some work, but it can't do a lot. And from our perspective, we're concerned with how much produce can I grow on a unit area, in this case an acre. So exchange capacity, the smaller your exchange capacity, the less calcium you need, because calcium is a percent, not a sort of parts per million. So on a low exchange capacity soil, you might only need 800 or 900 parts per million. In a larger exchange capacity soil, you may need 2,000 or 3,000 parts per million. But it's the 70% plus or minus base saturation we're looking for there. On magnesium, I look for 12 to 18%. Call it 15 if you want to be average. If I'm on potassium, I like to see 3 to 5%. Sodium between 0.5 and 3%. And then we get down into some of the trace elements. This is an area where many growers fall flat on their faces. They have not been addressing trace element deficiencies systemically for quite some time, and in many cases it's the deficiency of trace elements that are the root causes of breakdown deficiency disease in their crops. So starting with boron, a very important one. Again, like sulfur and anion, and in areas of the country where it rains a lot, I'll just about guarantee you that you have a boron deficiency. I like to see 3 parts per million present in the soil for boron for a high-functioning soil system. Boron facilitates calcium availability. There's all these interconnections and interrelationships between these minerals. So I like to say 3 parts per million of boron. Next would be manganese. Manganese is critical for fruiting, reproduction. You need to have manganese in every seed for it to germinate. 80 to 90 parts per million is my target level for manganese. After that, copper. I like to see 4 parts per million on copper. Zinc, 8 parts per million on zinc. Cobalt, 2 parts per million. Molybdenum, 1 part per million, and selenium, 0.5 parts per million. It's a few minerals. It's not anywhere near as many as we really need, but it certainly is enough to dramatically improve, in almost all cases, the growth of their fields. If you can bring those mineral levels up to those levels, you will get dramatically increased vigor and vitality in your crops over time.